Should.
Okay, great. Okay, great. Thanks a lot, Jane, and thanks for inviting me to come and give a talk on containers. I gave a talk a little while ago that was a little bit more kind of, I guess, technical and more latest greatest changes. But today I'm going to be talking about a little bit more kind of introductory, just kind of like containers and high performance computing. So my name's Dave Godlove. As it says here, I'm a solutions architect at CIQ. CIQ is the company that supports Apptainer, among other things like Rocky Linux, for instance, and Fuzzball, which I hopefully be able to talk about a little bit today, and also Werewolf, Mountain, Ascender, and a few other products as well. So without further ado, today I'm going to be talking about just like introductory, what are Linux containers at all? And I'm going to talk a little bit about what is Apptainer, and then I'll talk about how can high performance computing users benefit from using containers. And then I'm going to talk about how can HPC admins benefit from the use of containers. And then if there's a little time at the end, I'll give a little preview about container orchestration, taking the next step beyond just running containers and going into orchestrating containers, specifically from an HPC jobs perspective. Okay, so level set. What are Linux containers? In a very brief kind of nutshell, containers allow you to take an application and package it along with all of its dependencies in one little unit that ends up being portable and reproducible. So that's kind of what containers are in a one sentence summary. You can think of containers, and I think that even it's new people using containers, and even maybe people who are more familiar with containers, I think it's useful to think of them as lightweight and highly performant virtual machines. Now that's kind of like a metaphor. It's not really technically what containers are, and there are some important differences between containers and VMs, but just for their use, I think it's a good analogy to just kind of think of them as though they're virtual machines, but they're really lightweight and fast. So here is kind of like the the one of the most simple demos that you can do to kind of show what containers are. So here on this system, I've run the Python command. I want to jump into a Python interactive shell and do Python things. But on the system, I don't have Python. So if I do that, it says that the command is not found. So, but since I have Apptainer installed, I can just do an Apptainer exec. This is going to execute a command within a container. I'll specify that the container is going to be the default Python container up on Docker Hub. And then the command that I'll run will just be Python. And when I do that, I'm immediately dropped into a Python shell, even though I don't have Python installed on the system. So this is kind of like, this illustrates one of the great things about containers and why they're widely used within HPC. They give you access to operating systems and software that you don't have access to normally, essentially, with a lot of ease. So what is Apptainer? So Apptainer is a Linux container platform which was purpose-built for high-performance computing. The story behind Apptainer is that around 2015, containers were gaining a lot of traction in the DevOps community, what ended up becoming the cloud native community. And HPC users started to hear from their developer friends about containers and started to approach HPC administrators and ask them to install tools like Docker within the HPC environments. So admins, by and large, went and started to look at these tools and decided that they were not a great fit for the multi-tenant HPC environments that we work in. And so a community started to come together to create a container solution, which was a more appropriate fit for HPC and which was purpose-built for HPC. And that community ended up developing something called Singularity. And the story of Apptainer is that a few years ago, a bunch of people in the Singularity community went to the Linux Foundation and said, would you support Singularity as one of your supported projects? And the Linux Foundation had a look and said, yes, we would, but we want you to change the name from Singularity, which is somewhat ambiguous and which has some corporate baggage associated with it, to something different. And so the community got together and voted, and we voted to change the name to Apptainer. So that's, kind of briefly the story behind Apptainer. And you can see why it's really a great fit for HPC, because it was purpose built for HPC, both from a security perspective and also from like an ease of use and HPC centric perspective. So how can HPC users benefit from the use of containers? So one of the ways in which HPC users can really benefit from the use of containers is that HPC software can be really difficult, notoriously difficult, in fact, to install. A lot of times the people who are building HPC software are scientists who are very knowledgeable about the type of data analysis and the algorithms that they need to use, and making things highly performant, but they might not have a software engineering background. And so because of that, they might be less knowledgeable about things like providing good installation pathways for their software, or providing good documentation to help users use the software. So I'll give you kind of an extended example, and I'm sure as HPC users, a lot of you have been in this situation or a similar situation. Let's say a lab in the domain that you work publishes a paper, and they have developed some new software. And this new software you really have to use in order to stay current within your domain. So what do? You go to GitHub, and thankfully that other lab has posted their software on GitHub, and they have a README document, and the README document has installation instructions. So far everything's great. You go and you read the installation instructions, and the first line says, just do sudo apt-get install the following 10 dependencies, and then do like a pip install of the package, that we wrote. So now you're in trouble, because you can't do sudo in your high performance computing system. You don't have admin privileges as a user. And you can't do apt-get because this is not an Ubuntu or Debian based system. This is enterprise Linux. So it runs off of yum or DNF. So you've got two major hurdles. Now, what are your options? Well, you could go off and try to figure out how to install all of those dependencies manually, and then configure, your pip install to point to those dependencies. And that, might end up wasting you weeks. Or you could go to an administrator and say, hey, I really, really need to install this software and run it. Could you do that for me? And then they're going to be stuck in the same boat. That's what they're going to have to do, is go off and find all those dependencies and try to install them manually. Well, as an HPC or as a container user, you've got a third option available to you. Actually, a third and a fourth. Your third option is, you could say, well, that's easy enough. I can just spin up an Ubuntu or a Debian container, and within that container, I can do an apt-get install, all these dependencies. I can install Python, and I can do a pip install of the program, and I can be, off to the races. Or your fourth approach, which is probably even easier, you can say, I can go up to Docker Hub or, some other public registry, and I can look to see if anybody's already created a container with this software in it. And in fact, maybe the lab itself that originally created the software has already got a container, and I can just download the container and run it and have instant access to this software, which would otherwise be really difficult to install. So that's one, big benefit that HPC users get, is, access to this difficult to install software. Another thing that HPC users get by leveraging containers is that they can use HPC specific hardware with custom software. So I'm talking here about things like GPUs, high-speed interconnects like InfiniBand and OmniPath with MPI jobs, things like that. So Apptainer makes it really easy to leverage this kind of hardware, because once again, it was built for HPC environments. Just to kind of like to further illustrate this point, there's a really, really influential software which has come out that Google created a few years ago called AlphaFold, and that's used widely within HPC. If I go ahead and I click on this link and I go to the GitHub for AlphaFold on the installation page, the installation instructions, the very first thing that they say is install Docker. So AlphaFold is so complicated to install that they're not even going to give you instructions for how to install it. If you want to try to figure that out on your own, good luck. They're going to say, the very first thing you need to do is you need to start using containers. And if you go then to the next link that I've got, if you actually go up on GitHub and you find the most downloaded version of AlphaFold, which is this version here, the most widely used container for AlphaFold, you'll find that the author, maybe I'll make that bigger just to make sure everybody can see it. The author of this version says right here, if you plan to use AlphaFold in an HPC environment via Singularity or Apptainer, here's an easy script to do it. So, really more and more software is going down this road of, the expected path is that you're going to use it through containers. So how can HPC admins benefit from using containers? Well, one really obvious benefit that you get as an administrator is that it reduces the load of app installations that you have to do. So if you give your users the ability to kind of do self-service and install and manage their own applications, they're going to use that, and that's going to take some of the load off of you. It also eases your ability to install applications and manage those applications, even when users still come to you and ask you to install apps. So because you can use containerization to install applications on users' behalf. Now, this presents a little bit of a paradox because by definition, it's going to be the least experienced users probably who come to you and ask you to install software on their behalf. And if you're installing that software through containers, you're kind of taking your least experienced users and you're expecting them to use this advanced container technology. So because of that, there have been methods developed to allow you to install and manage applications on behalf of your users in ways that make the containers completely transparent to the users. So you can install your applications in containers and you can manage those installations through your normal module files, the way you would normally install and manage any other application. And your users can load a module and then run those containerized applications and not knowing anything about Linux containers, not knowing anything that they even exist. And those applications will run on the system and appear to just be installed right on the system. And so so I used to work at the NIH. I used to be one of the administrators of BioWolf at the NIH. And this is, a method that the NIH has really embraced. You can read more about the details of how to do this here. And this is kind of an old repo. I put this up a while ago, but this is a list of some of the applications that the NIH has installed through containers in this transparent way that users don't even know that they're using containers. So it's kind of an extensive list. And this is just a partial list. The NIH is an interesting place because they admin close to 1,000 applications on users' behalf and have to manage all those applications. So they need, really good, robust methods for doing that. Okay, so now I want to talk a little bit at the end here about container orchestration. So it's really, anytime you talk about containers these days, it's not a complete discussion unless you at least mention container orchestration. And I want to highlight, this is from a job perspective. So traditional...
Hey, can I just interrupt just quick? I know everybody's going to ask me, are we going to be able to get a copy of your slides to share with everybody?
Sure, absolutely. Yeah.
Okay, great. Thanks.
Yes. So traditional orchestration solutions, I'm talking about things like Kubernetes here. They're really specialized for running like long running services. And so because of that, they have a lot of knobs and buttons and things which aren't really applicable to jobs. In HPC, that's what we really need to orchestrate, orchestrating jobs and not long running services. So our use case is a little bit different. So just like Apptainer was purpose built for HPC because the container solutions at the time didn't really cover the HPC paradigm very well, there's a new tool called Fuzzball, which CIQ is building for job orchestration because once again, job orchestration is not being covered in the HPC space very well. So I'll just give you a little kind of taste of what that looks like. So Fuzzball allows you to orchestrate jobs using, or orchestrate workflows, which are composed of one or multiple different jobs working together via YAML files. And so this is what a very simple YAML file for a single job running MPI looks like. And so this is a little MPI hello world. It runs in this container. There's secrets to get the container. And then if you actually submit this YAML file to Fuzzball, then it'll go and get the resources that it needs, spin your job up, and then you can get logs out of it like here. So this is a completely command line tool if you want it to be. But there's also a web interface for this. And so Fuzzball is completely API driven. And so anything that you can do in the CLI, you can also do through the web GUI. And if your users or you as a user are not really comfortable learning the YAML spec for Fuzzball and you don't want to write your YAML files, we've got this workflow editor here, which is really great. So you can, drag and drop and put these jobs here, and then that'll generate a YAML file for you that you can further edit if you want to. This is what it looks like if you submit your job through the Fuzzball web GUI. So once again, we've got the logs here. These are the same logs I showed you a minute ago. This is what the workflow editor looks like if you are stringing together jobs in a workflow and making them dependent like this. This particular workflow is a GROMACS workflow. It uses GPUs and also uses MPI. And Fuzzball understands these technologies and just, you basically check boxes and say you want to use those things, and then it allows you to use them. And then this is just to illustrate that, your workflows can be really as complicated as you want them to be, as long as they're not cyclic. As long as your workflows are acyclic, you can, anything you can come up with, you can put together in Fuzzball. So that's something that we're kind of like still working on. It's something that we're excited to start rolling out here pretty soon. But I just wanted to give you a little taste to show you that CIQ is thinking about not just, containerized jobs, but also orchestration and what that looks like within HPC. All right, so that's pretty much the end of my talk. I told you a little introduction about Linux containers and Apptainer in particular. I told you about how both users and admins can benefit from using containers within HPC. And then I gave you a little taste of job orchestration through Fuzzball. So with that, I'll hand it off to I'll either take, I don't know the format, I'll either take questions or I'll hand it off to our next presenter. But yeah.
I think it'd be great if if anybody has any questions that they'd like to ask Dave now. And just to, I'm not sure of our preface to you, Dave, but a lot of these, the attendees and the people in our community are, we're called emerging centers, but a lot of people are either running centers or centers. They may be one person at an institution, a higher ed institution that's just supporting researchers using a small cluster, all the way up to people that are managing larger centers. So I think, if anybody has any questions. I guess I have a question. Are there technical requirements for the people that maybe have smaller clusters? Are there technical restrictions and requirements that you have to be able to run containers, or can this kind of run on any platform?
Yes, that's a great question. So if we go back to the history of Apptainer, the real big reason that it was created was that there wasn't a good way for unprivileged, kind of untrusted users within an environment to run containers. The biggest solution at the time was Docker, and Docker requires you to be added to a group that has elevated privileges and allows you to run containers with elevated privileges. So Apptainer allows you, without any kind of special software, to be able to safely let your users run containers without really escalating their privileges in any way. Now the technology that allows you to do that has been changing over the course. So when Apptainer was first created, it handled there are some privilege escalation things that have to happen behind the scenes. You have to mount a file system to your node in order to have a container. You have to create a new mount namespace in order to have a container. And these are privileged operations. So Apptainer installed a root own set UID program to escalate privileges enough to allow your users to do those things and then back the privileges off and drop them. Now, we no longer need to rely on that because there is new technology called the user namespace, which is, it's not, the technology itself is not so new, but its adoption within HPC is new. So if you do have the user namespace enabled and properly configured within your HPC environment, that's something that you might rely on. But if you do that, then you can actually install Apptainer completely unprivileged without any SUID bit workflows or anything like that. And then you can just leverage this Linux kernel feature to escalate privileges, through namespaces instead, and set your containers up.
Very good.
Question. Well, it looks like nowadays we have the luxury of having more than one choice. So Apptainer is one. So there's also Podman, there's also Enroute, and so on and so forth. So could you comment on, like, so the pros and cons, and the entire ecosystem and where it's going?
Sure. Podman that you brought up. So Podman, I think that its goal was to basically be a Linux or a Docker replacement. So a drop-in replacement for Docker that runs without a daemon and can run unprivileged. And the buzzword there is rootless. And so I think that Podman sort of goes along the same lines as Docker, as like what its goals are more to provide containers for like cloud native microservice architecture kinds of applications. It works pretty well with something like Kubernetes. It's still not, it overcomes the security hurdle, which just prevented Docker completely from being installed in HPC environments. But it still doesn't have kind of like the intelligent defaults that make it convenient for an HPC user to use. So it's more geared toward a different community. And then the other big difference between Apptainer and pretty much any other container solution is the singularity image format, or SIF files. So SIF files encapsulate containers in single files, which makes them convenient and easy to manage. You can just move files around, and if you can do file management, you can manage your containers. But the bigger thing that it does beyond that is it enables things like cryptographic signing and verification of your containers and encrypting your containers. Other container technologies allow you to do that, but they do that at the level of the registry. So there's this whole thing called, this registry that you have to push your containers to and download your containers from, and it's kind of a vital part of the whole container workflow. With Apptainer, you can take the registry out of that, and you can just sign your containers because they're a file, and it's actually the file which gets signed and stores the signature. And you can do the verification on. And same with encryption. You can encrypt that file, and then the container, it's not encrypted up on a registry and becomes decrypted when you run it. It's encrypted on disk, and it's actually remains encrypted on disk even when you run the container. So those are some of the advantages and differences between Apptainer and other container platforms in the space.
All right, thanks.
I guess a follow-up question to that could be, there's Kubernetes, and then now I've not heard of Fuzzball. It doesn't mean that that's, but Kubernetes is the one that I guess I think about it for orchestration. So would you be able to compare those two tools?
Yeah, so Kubernetes is, like I said, it's fantastic for orchestrating services, right? So and this is really baked into the Kubernetes architecture at a deep and fundamental level. So, Kubernetes really, really expects that when you start a container, you want that container to run forever. And it's going to provide a lot of tools to help you in that endeavor of running your container forever. And so, because of that, there's stuff like, there's stuff like if the VM fails underneath your container, it's going to figure out a way to make sure that it's going to spin up a new VM. And if too many service requests start to hit your container at once, it's going to figure out how to spin up multiple different versions of that container. If you take advantage of that, it's going to do things like load balancing and stuff. And so there's all this stuff baked into Kubernetes that is really, really great for running services that doesn't help you a bit when you're running jobs in HPC. And so you might say, okay, well, just don't use all that stuff. But you can't, the way in which our Kubernetes, and you'll see this when you start to learn to use Kubernetes, the way in which it's put together, it doesn't allow you to just not learn about all those things. You have to learn about all this other stuff that's not applicable to you as an HPC administrator or user in order to use this tool. And so you're kind of, if you're using this for jobs, and you see this, there's lots of different projects that are trying to use Kubernetes for jobs, and they're all kind of taking this tool and shoehorning it into something that it wasn't really designed for. So that's where Fuzzball comes in. So Fuzzball would be an awful solution to try to run a big microservices application, in the cloud. That it wouldn't work for that at all. But it's a great solution for running jobs, orchestrating jobs into a workflow within HPC. So the basic idea with Fuzzball is it actually runs on top of Kubernetes. It is a service that sits up in the cloud somewhere or on-prem on your cluster. And it waits for requests. It waits for YAML files to be submitted to it. And once it gets one of those YAML files, it looks at what the resources are that are required, and then it goes out and asks for those resources, CPUs, memory, nodes, all that kind of stuff. Once it gets those resources, it creates a pool of resources for your job, and then it grabs containers and pulls them to those resources. And then it sets up any volumes that you need so that you've got storage associated with that job, and they're attached into those containers. And then it starts to execute commands within those containers that it just pulled to those resources. And that's basically the way it works. And then like in the cloud, for instance, when it's done, it releases all those resources. So you don't have a bunch of like VMs sitting there just wasting cycles, waiting for work. It sort of creates that stuff on demand and then gets rid of it when it's done, so that you don't have to have like a virtual cluster just sitting there doing nothing, waiting for people to submit jobs to.
And running up charges that nobody can afford.
Right.
Yeah. And did you say the Fuzzball is available now, or is this something that you're getting ready to release?
It's sort of available now, but with limited, it's not, it's got limited functionality at this point. It's sort of available in like demo mode now. So, and yeah, it's not something that you can just log into and play with yet. It's something that you would have to contact CIQ, and then we could set you up with like a demo or something.
And is that open source?
Not currently. Yeah. We're developing, it's kind of like the same way that Podman started off in Red Hat being like closed source and developed internally. We're still in the development phase of Fuzzball. So, it might be open source at some point in time, but right now we're still kind of just developing it.
So our other speaker wasn't able to make it, so we do have a little bit more time. If anybody had any additional questions, you can unmute and speak up or put it in chat. We have a quiet group today, which is not typical. They must be cold. Well, I have another question. We have a new chief medical digital officer. And so he's very interested, in this new, well, not new, but kind of new, the new policy for having to share all the NIH data that's around research. I don't know if you're aware of this, but one of his ideas is to make things easier for our College of Medicine faculty and researchers is to create containers that I think it sounds to me like when you're talking about the workflows and something with fuzzballs, so that they just can go and they don't have to know a lot about even the tools. They just know that maybe this is an AI workflow that you can run this container to run your systems. Does that make sense to you? Something that we should be looking at?
Yeah, absolutely. Like abstracting away a lot of the details about, installation and management of the underlying applications, and also abstracting away a lot of the details about how applications need to be strung together and one needs to be run after another within a pipeline. Those are exactly the kinds of things that containers and container orchestration are going to do for your users. I could get up on my soapbox a little bit. So, so when you start talking about abstraction, I feel very, very strongly about abstraction because I've dealt with a lot of abstractions that were incomplete. And I think it's common, especially in this domain, you'll have like a scientist that'll say, for instance, well, a lot of people in my lab don't use HPC and they don't know Slurm and they don't know, and we've got some workflows that run really well through the HPC. So I'll create some abstraction where I'll have the scientists just drag and drop some data into a particular shared directory somewhere, and then I'll have them press a button and everything would just go up and run on Fuzzball, and they won't, or on not Fuzzball, on Slurm, for instance, in the HPC cluster, and they won't have to learn about how all that stuff works. And it'll work like 90% of the time. And this is where we run into trouble. So a lot of times people think, well, if my abstraction works 90% of the time, then I'm saving my end users like 90% of their time, right? And actually, no. If your abstraction works 90% of the time, you're wasting a ton of your end users' time, because what you're saying is now, not only do you have to learn all the underlying technology, because you're going to have to learn that anyway, because 10% of the time this thing's going to break down, but now I'm going to put on top of that all this other stuff that you're also going to have to learn in addition to learning the underlying technology, and which might like insulate you for a while from learning the underlying technology. So if you take it upon yourself to create an abstraction, in my mind, it better work like 99.9% of the time. We don't need leaky abstractions. We need things that are going to work. Otherwise, you're just wasting everybody's time. And so that's really what we're striving for, when we're looking at Fuzzball and containers and stuff like that. We don't want the end user to ever have to say, oh, no, this thing broke and it's giving me some error about containers that I didn't even know I was using containers, and I've got to go figure this out. We don't ever want that to happen. We want, when you're doing these abstractions, we want the end user to pretty much always be insulated from this stuff. So that's my soapbox on abstraction.
I like it. That makes a lot of sense. It's like if you're using a GUI and then all of a sudden it pops you out to DOS. I mean, who would know, the DOS command line, who would know? And then they'd be like, forget it. I knew I shouldn't use this system anyway. And I should have just stayed with my own workstation, which is something that, we definitely run into with our, especially with this new user base of HPC researchers and users that really don't want to know command line and don't want to, they really, and I'm seeing it more and more, at least for the University of Cincinnati, where I am, we had probably 80% of our users a year ago were engineers. Now, 60% of our users are in our College of Medicine, and 40%, well, 30% probably engineers, but then we also have digital humanities. We have, we have an ever growing pool of users that they really do not have time or want to know about what happens behind the scenes. So that's, I think, containers and any sort of abstraction like you're talking about, open on demand is another thing that's really changed our user interfaces, that some people still want to do the shell, but even the Ohio Supercomputer Center, who their team created open on demand, they say 90% of their users now even get to the shell through open on demand. So, there's this is really important information and work that you're doing. I cheer you guys on. Let's see, Alex Feltus, it looks like he has a question for you.
I just want to follow up on your soapbox. So like, and with this abstraction, like, so I teach hundreds of people, how to get on the command line. I'm a biologist. And so it's really important. I'm sure a lot of people on this call understand this, but like the concept of typing a command, I mean, Jane brought this up, or knowing what a file is other than something you poke or click is incredibly foreign. And containers, containers are a godsend, right? I mean, I use that to be able to do complex workflows to people that barely know how to use the command line and know how to change file names and know where files are. But if you don't have that really basic thing, if you abstract it into a GUI or something like that, it's gonna fail 100% of the time if somebody needs to change their file location for, or load it into a container. The concept of like moving a file from a laptop to another, or remote sources, is so hard to teach to people. They don't understand.
Yeah, and but I also I don't want to sound like I'm saying that all the scientists need to learn like all the gory details, because so I used to be a scientist before I was an administrator, right? And like I was a neuroscientist, and I had to learn surgical techniques, and I had to train monkeys, and I had to learn just enough like chemistry to be able to and there was all this other stuff that I had to learn. I had to read the literature, and I had to stay up to date in my field, and I had to, and so scientists who have all that other stuff on their plate, it's not realistic to also say, by the way, we want you to be computer scientists as well, and learn all this other stuff. So I'm not making an argument against abstractions. I think I'm making an argument against leaky abstractions. I think that what we need is so like open on demand, for instance, was brought up. Open on demand is wonderful, but I do think that so the open on demand offers a terminal that you're expected sometimes to use. What if we remove that? And what if we said that, open on demand is so powerful and the abstraction is so complete, you will never need to use this terminal, so I think that's kind of like what I envision. Ultimately, I think that it would be great if HPC end users actually could get away without learning how to do SCP or rsync or something like that. They could, the abstraction was complete enough that they could understand how to just drag and drop their files around and analyze their data and never get back to that, never resort to command line tools.
That's interesting, because that my entire philosophy is teaching command line up. Like, you have to use the command line to biologists, and everybody's afraid. They're like, oh, I can't program, I hate you. And after a while they love it, and they get into the creative space of the command line. And really my goal is always, what is a file? Where is a file? Can you change a script to change the name of your file? Like, the last thing I want to do, because as teach computer science, create more computer scientists in a field that isn't computer science. It's not going to happen, and I'm not a computer scientist. But enabling people, I think that if you got rid of the command line, like if the command line was gone from open on demand, I would never use open on demand anymore, because everything's got to go through the command line to do data intensive computing. If you're going to exec into a container, you have to have some kind of concept of typing a command. Like, that is so hard to type a command because everybody's used to click and everything. But anyway,
well, and that is the reality. And I've taught a lot of people command line stuff too, because that's where we're at right now. That's where you have to learn that stuff. But yeah, I'm just kind of trying to think about, like, could we imagine a world in which we get a bunch of biologists who come in to use HPC, and they're biologists, and they don't, they use their computers to check email and write papers, and that's about it. And that's okay. And they can continue to just do that as they use advanced high performance computing resources.
But what happens when they are doing exascale computing? Like, I mean, single cell RNA-seq, when we start to get it as like the kind of depths of sequencing from bulk RNA-seq, and people are going to have petabytes and exabytes of data, and there's no way they're ever going to be able to just click and move stuff. They're going to have to go in and hack. You can't hack without the command line.
Yeah, I mean, there's always going to be a need for some level power users to be able to go in there and do things like that. But yeah, I do think it would be nice if not every single user had to, you know, play with the command line. If there was some subset of users that could get by with, you know, just straight through the GUI forever.
It's amazing to me how Jupyter Notebooks has become really the interface of choice for a lot of our users, because they don't even, you know, they don't even want to look at the software anymore. They like, you know, doing that. So that it's right. I agree that I think there's always going to be this subset of power users and people that are going to be moving to the exascale before, but really, I know at least from our point of view, 80% of the people, you know, don't want to have anything to do with that. I kind of liken it to, you know, opening the window on my car. Like, I don't really care what happens when I press that button. I just want that window to go up. And, you know, before we would have at least, you know, we're kind of like moving in a continuum of, you know, maybe at some point you had to actually pull the window up, and then you had a manual crank. So you kind of knew that you could feel that window was going up. Now it's like you press that button and who cares, you know, and I just want to press it and go on. But that's, you know, so I think we need all this whole range of things to do, because like I said, HPC and advanced computing, advanced research is including every discipline in every field. And specifically and especially in higher ed, the people on this call and part of this community, we have to support all of them, from the engineers to, you know, I have musicians who have a ton of recordings that they want to do data analysis on. So, you know, but they're a clarinetist. I mean, you know, never ever do they want to even learn. They don't even want to see a command line. So we all have a big challenge ahead of us to be able to keep our researchers smart enough and keep up with them.
I love your analogy, Jane. And if I would just, like, you know, go down that metaphorical path a little bit further, I would say that what a lot of us are doing right now is like saying, okay, well, we'll let you use the button to raise your window up or lower it down, but it's going to fail, you know, 10% of the time. And there's a crank in the glove box. And we want you to like figure out how to get that crank out and use it when you need to. And our ultimate goal is to get you away from that button and just get you using the crank all the time. And of course, you know, how silly is that, right? There's a subset of users that the ultimate goal should be, you know, become familiar with the GUI. But I think that a lot of us, as admins, we tend to say, okay, well, a GUI is going to be like a transitional step, which is going to get you started. And then from there, you're going to learn a little bit of the command line, and we're going to get you further and further down until you're proficient with the command line. And that's not really, I don't think, I mean, for some power users that need to do that, fine, but not every user needs to go down that path. Some of them just need to be able to press the button and raise the window, you know?
But if you're doing genomics, you're a power user. You have to be a power user. There's no way around it. So like that's my philosophy, is that everybody that does anything molecular, I'm talking about from a biology perspective, and I can map it to other disciplines as well. There's no way around it. And so everything's broken. Like all bioinformatics software is inherently broken, and you have to be able to hack through it. And so it's always going to be that way. I don't think there's going to be some magic, you know, standard. It's not going to happen. I mean, research has got to evolve and everything. So I just think that the GUI to me is like, if you start them off in a GUI, you start them off in a painted corner. If you teach them the command line, then they can paint the neighborhood. That was kind of lame.
I think, yeah, you said it right when you said you guys are power users. And it wasn't lame. I kind of liked your painting. So
Thank you.
sure. Somebody else have any comments? I wanted to point out that in the chat, let's see, Jim put in the details for tomorrow's systems facing track call. And do we know what time that is? Maybe you put in there what time it is, but they're going to go a little bit deeper dive into containers. And you know, that's kind of one of the good things that around having these different facings within the People Network, we kind of have 1 p.m. Thank you. So you can get different points of view around the same topic by attending different sessions. So I encourage everybody who's interested in finding out a little bit more, or finding out just hearing it again, to please attend the systems facing. Dave, will CIQ be at Supercomputing Conference?
Yeah, absolutely. We're going to have a fairly large booth, I think. And I think this year we're going to have a PA system and be giving some talks and things. And so, yeah, definitely check us out.
Very good. Well, thank you very much for coming, and sorry about the technology. Oh, there's a link to the doc in there in the chats. I'll be posting the recording on our YouTube channel, and I'll send a link out to everybody, including you, Dave, so you can share with whoever you need to share with. And if you can send me or Rich, I'm not sure whose emails you have, your slide deck, if you don't mind, and then we will send that out to the group. Is that me making that noise?
Absolutely.
Okay, does anybody else have anything that they would like to add? Let's see if I make sure that yep. Thanks, Alex. I think containers are amazing too. And we probably could have 6 more calls like this where we all just need to kind of hear, and then, but can people reach out to you too, Dave, if they have questions?
Yeah, absolutely. Yeah.
Okay. All right. I'll link, I'll put your email in there also, if that's okay.
Yeah, that's totally
Yeah,
okay. Thank
right.
you very much. Thanks.
And we'll all look you up at SC. So, okay, everybody, thank you for attending. And with that, I'm going to stop the recording.
Thanks.